Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website, arifpat.me, and you can click the appropriate link under the lecture resource column and view the notebook in NB Viewer and run it online in Binder. Well, the other way is to download it from the course GitHub account, Arif and all the notebooks for this course are housed in the public data science repository over here at this link. Well, this is the Jupyter notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture number 3.6 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. My dear students, this is the fifth session, rather the sixth session on the NumPy arrays, and today we are going to see how we can manipulate the NumPy arrays, 1D and 2D. We'll see how we can modify the values, append new values inside the NumPy arrays, insert values in between, delete elements, and finally we will talk about aliasing, shallow copy and deep copy. My dear students, before I continue, let me have a very quick recap of the concept of axes in 1D, 2D and 3D arrays, which we are going to deal with again in today's session. So over here, if you see this image, this is an array named A having a single axis, and that is axis 0. Remember, axis 0 is the vertical axis, moves from top to bottom, 0, 1, 2, 3 and 4. So this array has a dimension of 1 because it has only one axis. It has a shape of course, 1, 2, 3, 4 and 5 rows. And the size is also 5. That is the total number of elements. Simple. This is a 2D array, B. It has two axes, axis 0 and axis 1. As usual, axis 0 moves from top to bottom. It tells you the number of rows that this array has, 0, 1, 2, 3, 4. So this has total of 5 rows. And this axis 1 moves from left to right. So it tells you about the number of columns this array has, 1, 2, 3, 4. So the dimensions of this matrix is 2. The shape is 5 rows, 4 columns, and the size means total number of elements, and that is of course 5 into 420. And to access a specific element, you know this is the 0th row and this is the 0, 1, 2 second column, and over here this is the 0, 1, 2 second row and the first column. Great. Let's talk about the 3D matrix as well. This C is a 3D matrix. It has 3 axes. Axis 0, which moves from top to bottom, specifies the number of rows this matrix has. This is axis 1, moves from left to right, specifies the number of columns this array has. And this is axis 2, which moves towards the depth. So, and this axis right now shows that it has 3 levels, 1, 2 and 3. And similarly, we have 3 values using which we can access a specific element of this 3D array. So the dimensions are 3, shape is 5, 4, 3, and the size is of course 5 into 4 into 3. So I hope this concept is clear. Let's move ahead. So if you have not installed, please install NumPy. The version I am running right now is 1.19.5. So first of all, let's talk about updating existing values of NumPy array elements. So this is very simple, my dear students. You can use just the subscript operator and you can specify either the positive index or the negative index. And remember, the positive index starts from 0 and the negative index starts from -1. So in case of 1D array, it is a piece of cake. So this is a 1D array and we have changed the element, the value of the element at index 2, 0, 1, 2. So we have changed this 6 to 333. Great. And over here, this -1 means the last index, 73, and we have changed it to 777. Okay, let's talk about 2D arrays. My dear students, in case of 2D arrays, suppose I have created this 2D array using the rand-int method of the random module. This is a 4 by 4 matrix having values spread from 1 to 9. So over here I have used two indices 0, 1, 1, 2 and 2 minus 1. So let's understand this. Understand this last one. 2 minus 1, that means 0, 1, 2, and over here the column is the last one, that is -1, and this is the element which I am going to change in this line of code, and I'm going to change it to 22, and I have changed it to 22. So I think this is simple. Let's move ahead. Let's talk about appending new elements to the NumPy array. My dear students, you can use this append method of the NumPy module to insert new values, and these values will be appended at the end of the NumPy array. And remember, the method will return a copy of the existing NumPy array with the values appended. And the arguments that are passed to this append are the required arguments are the name of the array in which you want to append and the values argument. So the axis can be specified. By default it is none. If it is not specified for a 2D array, the ARR or the array is flattened before use, and if this axis is specified, then you need to keep in mind that the values should be of the correct shape so that they can be appended to this array. Let's see this practically. And once again, this is not in place, so the original array remains as such. So appending in 1D array is a piece of cake. This is just a single array of size 10 having elements spread between 1 and 99. You can add a scalar value as well, and you can add a list of values as well at the end of this list. So I have just added the values, 3 values at the end of the list. Just watch it. So after this 49 over here, I have added 3 values 101, 202 and 303. So these 3 values have been appended. And one more thing is that the original array remains as such, and you get a copy of the array. So if you note down that the IDs of both the arrays are different. I hope this makes sense for 1D arrays at least. Excuse me. Let's talk about the appending elements in case of 2D arrays. My dear students, in case of 2D arrays, if you do not mention the axis, I have, as over here I have not mentioned the axis argument. Both this ARR and these values will be flattened before use. So this ARR will be flattened, 753368337. It will be flattened, and then these values will be appended at the end. So we will have 9 values of ARR1 flattened in shape of 1D array, and then these 5 values will be appended at the end. Let's run it. See, so these are the values of ARR1 flattened, and then these are the values which we have appended. So this is the case when we do not mention the axis argument. Okay, so let's see what happened when we do mention the axis argument. Okay, consider this 2D array. This is of size 4 rows and 3 columns. And now over here I am using append method to append these values to this array along axis is equal to 0. My dear students, in this case you need to keep in mind that the values argument must be of the same shape as ARR, this ARR1, excluding the axis. So actually when you mention the axis is equal to 0, that means you are appending a row to this matrix. So if you are appending a row to this matrix, it must be having 3 elements so that it can be appended accordingly. That's why I have given 3 values over here. So this 101, 202, 303 will just be appended below this ARR1. Let me run it. You see, so this has just been appended at the end. So keep in mind that if I give wrong dimensions, it will raise an error. Great. So whenever you want to append an array inside a 2D array, you kept the axis to 0. And naturally, whenever you want to add a column to a 2D array, you keep the axis to 1. Over here we have a 4 by 3 matrix or an array, 2D array. And if I want to append a column over here at the end, after this 0, 1, 2, these 3 columns, I want to append a column over here. So I need to give a column vector of shape 4, 1. That is 4 rows and 1 column. So 1, 2, 3, 4. 4 rows and 1 column. So this is the dimension of the values that I need to append this time, mentioned over here, when axis is equal to 1. So you see this 101, 202, 303 and 404. This column vector of shape 4, 1 has been appended at the end of the existing 2D array. Great. Let's talk about insert now, my dear students. The insert method is used to insert. It is similar to append. However, in this case, you do mention the index where you want to insert. Let's see. So in case of 1D, once again, it is a piece of cake. I have created a random array of integers having 5 values spread between 1 and 99. So I'm just adding these 3 values over here. So at index 3. So 0, 1, 2 and 3. So over here these values will be inserted. So this 55, 66 and 77 will be inserted at this index. This 28 will be shifted ahead. You see, this 28 and 48 are shifted ahead. These 3 values are inserted before the mentioned index. And the index is 3, so 0, 1, 2 and 3. So before this 28, these 3 values are inserted. Hope this makes sense. Great. Now, in case of 2D arrays, remember, if you don't mention the axis, as in the case of append, the arrays are flattened first. So this is a 2D array of 3 by 4 shape, 3 rows, 4 columns. I am just inserting at index 4 this value 55, and I am not mentioning the axis. So this array will be flattened. 0, 1, 2, 3, 4. So before this 7, this 55 will be inserted. So 6494, 6494, and before this 7, this 55 is inserted, and then we have 7, 3, 2, 3, and so on. So remember, when you don't mention the axis in case of an insert, this 2D array is flattened before use. Great. Let me insert multiple values. We can always insert multiple values in this array ARR1. So over here I am saying that insert 55 and 66, these 2 values before index 4. So it will be flattened 0, 1, 2, 3 and 4. So once again, after 6, 4, 9, 4, these 2 values will be inserted. 6, 4, 9, 4. Then we have 55 and 66. I hope you are visualizing as I am moving ahead. Okay, now let me mention the axis this time. This is the array of size 3, 4. Fine. So over here I am in the insert method, I am mentioning the axis is equal to 0. So as usual, we all know that this is the axis 0 that moves from top to bottom. So I have mentioned axis is equal to 0. That means I want to insert a row. I want to insert a row before the mentioned axis, that is 2. So that means 0, 1 and 2. So before this row, I want to insert another row. But I have given a single value. Note how this value is replicated. You see? 0, 1 and 2. So before this is inserted. I have just mentioned a scalar value and it is automatically replicated. However, if you are mentioning the values specifically, you need to ensure that they must equal to the number of columns so that they can appropriately be inserted. So over here I am mentioning 4 values because there are 4 columns. 55, 66, 77 and 88. And if I mention more or less, of course it will generate an error. Hope this makes sense. Great. Similarly, if axis is equal to 1, that means I am inserting a new column. So over here I am having a 3 by 4 array, and I am inserting a scalar value 5, 5 at or rather before index 2. So that means axis 1 moves from left to right, 0, 1 and 2. So before this 6, 1, 5 or after this 3, 3, 5, I am inserting this scalar value 5, scalar value 55. Please do note how this gets replicated. So this after 8 and 3, after the 0 and first column, this column is inserted and this scalar value is replicated. Similarly, if you are mentioning the values like this, you need to ensure that they must be 3 in this case, that is equal to the number of rows. So 1, 2, 3, 3 number of rows. So I need to give 3 values. 55, 66, 77 has been inserted before index 2. So 0, 1, 2, this was the index, and before this index 2, this column is inserted. And of course, once again, you need to ensure that the compatibility issue does exist if you mention the axis. Great. Finally, deleting the elements, you use the delete method. This method allows you to delete values from the array from this index. And if axis is none, that specific value is deleted, and of course the array is flattened before use. Let me do this practically to you, show this. So this is an array having 5 values spread from 1 to 9. And let me delete from this array ARR1 the value at index 3. So 0, 1, 2 and 3. So this 3 will be deleted. It is a coincidence that the value at index 3 is also 3. So this 3 is deleted. Let me run it again so that you should not get confused. Once again it is 3. Okay, now it is not 3. So 0, 1, 2, 3. So this 1 will be deleted now. So this 1 is deleted. It is no more there in ARR2. Great. So this is deleting. And let's talk about deleting multiple elements at the same time. You can mention the values over here, the indices from where you want to delete. So I have mentioned 2 and 5. So 0, 1, 2. This 91 will be deleted. 3, 4 and 5. This 41 will be deleted. So 91 and 41, these two values will be deleted. You see, this 91 doesn't exist over here, and this 41 also doesn't exist over here. Great. Let's talk about deleting elements from 2D arrays. My dear students, this is a 2D array, a 3 by 3 array, and remember, if you do not mention the axis, this 2D array will be flattened before use. So this will be flattened 558, 796, 798, and we are deleting from index 2, 0, 1, 2. So this 8 will be deleted. You see, 5, 5, this 8 is deleted. And if I, let's suppose, say this 5, so 0, 1, 2, 3, 4, 5, this 6 will be deleted. You see, 7, 9, this 6 is deleted. Great. And if you mention the axis, so that will of course delete the rows or columns. And note over here in the delete method, I am mentioning the axis 0 for this array. This array is a 4 by 4 array, and we know axis 0 moves from top to bottom. So 0, 1, and 2. So this is the axis. This is the index which I have mentioned over here, this 2 for axis 0. So that means this row will be deleted. You see this 4, 6, 6, 8 is deleted. And similarly, if you mention the axis as 1, the column will be deleted. Over here, once again, we have a 4 by 4 matrix. I have mentioned the axis as 1, and we know the axis 1 is the horizontal axis that moves from left to right, and the columns changes once we move from left to right. I have mentioned 2 over here, so that means 0, 1, and 2. So this column 3995, this column will be deleted. You see, 3995 column has been deleted. Okay, so finally, let's talk about assigning, copying, and aliasing. This topic we have touched in case of the list and directories as well. Let me quickly revise this for you. My dear students, I have just created a NumPy array of 10 elements, and the element spread is from 1 to 9. And over here, I am using the assignment operator to assign this array to this array. So this is just an aliasing. This is just an aliasing. Note the IDs of the two arrays are same. No new memory has been allocated. And if you change some element of any of these two arrays, either using name ARR2 or using name ARR1, the change will occur in both the arrays. So I have changed the value at index 2 to 55 in array 2. It has also been changed in array 1. So this is what is aliasing, and it is done using the assignment operator. Let's talk about the shallow copy concept, which is normally said to be a view in case of the NumPy arrays. So one way of doing the shallow copy is using the slice operator. Note over here I am using the assignment operator, but over here I am using the slice operator. So this is an array, and I have created a shallow copy or the view of the array. Note in this case the addresses of both the arrays are different. However, if you make change in one of the array, that will also be visible in the other NumPy array. That is why this is called a view. On the contrary, deep copy performs the real task, and deep copy is done using the copy method. You call the copy method on the NumPy array, and in this case, if you see, both the arrays have different addresses. And in case if you change any of the array, the change will occur only in that array. Over here I'm changing in ARR2 012 this 7. I'm changing in ARR2 this 7 to 55. So this change will occur only in ARR2. So over here I have this 55, but in ARR I still have 7. So this is what is aliasing, shallow copy, and deep copy. Okay. Right, my dear students, that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.